All right. So today we're going to talk about systems of equations. This is section 3-1 in your textbook. This is a thing that you've done in Algebra 2 or Algebra 1 before, but we're going to do it this time around too. We're going to start with looking at just graphs of lines and finding where they cross, because the solution to systems of equations is the places on the graph where the lines intersect. And so first, I want to understand that when I solve a system of equations, I'm finding where two lines intersect, because that's when they're equal. And when they're equal, that's an important spot. So that applies to a lot of different situations. And we're going to see some of those situations today. So when I have a system of equations that looks like this, where I don't have y equals, I need to solve the equations for y first. And that will allow me to graph them, because I'll have slope-intercept form. And this is a skill that we worked on in chapter 2. So this is not new either. So I'm going to just quickly do that real fast. I'm going to add 3x here, add 3x here, and I'm going to write what I get over here. So I'll get 2y equals 8 plus 3x. I'm going to subtract 2, or sorry, not subtract, I'm sorry, I'm going to divide by 2, and I get y equals 4 plus 3 over 2x, okay? So the graph of that line looks like there's a 4, and then I go up 3 over 2, up 3 over 2. Copy that down, like this, like this, like this, like this, okay? Then you just draw your line through those. Perfect, look at how nice that was. I'll try to clean that up a little bit, like that. Okay, good. Now, next, I'm going to do the same thing for this one. I'm going to subtract the x, subtract the x, and then I get 2y equals negative 8 minus x. Then I need to divide both sides by 2 again. So minus 2, divide by 2, divide by 2, and then I get y equals negative 4 minus 1 half x. So negative 4, and then down 1 over 2, down 1 over 2, down 1 over 2, all the way down, and then we can copy that pattern out this way as well. And look at that, it crosses right there. So then I'm just going to finish this off. Then I graph my line, and then I see, okay, well, when these lines intersect, that means that they're equal. And so this spot right here is the intersection point. So the answer to this problem is the coordinate. So I guess step 2 is find intersection point. No, step 2 is to graph both lines. And then step 3 is find intersection point, which is here, and that is the point negative 4, negative 2. Okay, so our solution to this problem is negative 4, negative 2. I wrote it in parentheses, x value, y value. We can do all of this on the graphing calculator, and so I'm going to put this on my screen. I'm going to do the work that I need to do before I can put it in my calculator, and then I'm going to switch to a new screen that will actually show you how to do it on your calculator. So I'm going to solve for y. And I know that I need to do that because my graphing calculator only accepts it when it says y equals. So this first equation gives me y equals 3 minus 6x. This second equation, I'm going to subtract x, and then I'm going to move it down here. So I'm going to get negative y equals 4 minus x. Now, it almost looks like I'm done, but I'm not, because I have a minus y. So I need to divide by negative 1 to get rid of that. And I get y equals negative 4 plus x. Okay, these two functions, this one and this one, are what I'm going to need to put in my calculator. Okay, so I'm back, and I had to splice this video in, I know, but what the deal is we've done some applications, but now we need to just talk about some theory. So if I have what is that? If I have two lines that are parallel, and that's my system of equations, do I really have a solution to that equation? Then I say, well, no, there's no solution, because they never cross. And I remember that the system of equations has a solution where they cross. So I have to say parallel lines have the same slope, different y-intercepts. But a system of equations, a system with parallel lines have no solution. Okay, so if you find a place where you get something that's false, you're going to see something that says like 0 equals -4. This is false. If you see something like that, that usually means that you have a parallel line and there's no solution. Okay, if you have a graph that looks like this, but both lines look like that same line, like this, they're coinciding, they're the same line, we would say that there are infinitely many solutions. And we'll get something that says something like 74 equals 74, which is true, but it doesn't have any x's in it, so it doesn't tell me what my x value is. It doesn't have any y's in it, so it doesn't tell me what my y value is. And so if all the variables drop out and we get just a true statement where the same number is equal to the same number, then we have infinitely many solutions. If you have any other case, meaning you just have two lines crossing, this spot is one solution. So there is one solution when the lines intersect. This is basically what that slide says. There's some vocabulary here, but I'm not going to be super picky about this consistent, inconsistent, dependent, independent thing. What I need you to understand is intersecting lines have one solution. Coinciding lines have infinitely many. And parallel lines have no solution. That's it. You have a worksheet to do. After you do the worksheet, you are going to turn it in, and you're done. Make sure you also turn in the worksheet that I assigned on Tuesday. I'm going to be checking both of those, and both of those are going to be going in the gradebook. If you need a new copy, the one from last week, Tuesday, they're in the Algebra 2 bin in the back corner of the room. Have a great day, and I will see you on tomorrow, Tuesday. Goodbye.